That's my alarm. It tells me we should start. It's 2 o'clock. So, everybody, please take a syllabus, and this is 105 class. Next room, you should, yes, that's 105 class. If you remember, it was a room switch. So if you want to take 106 class, you shouldn't be here. You should be next room. Normally, if you enter in the room and you see something on the screen, you should read it. Now, my name is Valentin Voroshilov. Can you read this? Anybody? I might need your help sometimes to be my translator. As you know, as you can hear, well, that's my official name for students. You know, much easier and simpler than that one. So all my students call me Mr. V. As you can hear, English is not my native language. In fact, unfortunately, I have no formal education in English. So I learned it on my own, and my grammar, my pronunciation, my vocabulary, of course, are far from perfect. That's why you may be handy. And I also have slight speech deficiency. And I haven't been talking in English for like, well, 2 months, yeah. The spring break is very long, so it's going to take a while to regain that capability, and I have to force my throat muscles to work in a certain way. That's why I might sound weird, too loud, too quiet. Ignore. All you need to know, if you have a question, you just have to raise your hand and ask a question. And there's a chance I will answer. It depends. You'll see. So I've been teaching physics, mostly physics, but not just physics, math, algebra, geometry, logic, problem solving for many years in different countries, on different continents. Middle school students, high school students, college students, university students, middle school teachers, high school teachers, students with learning disabilities. So I have a pretty good experience in teaching, and trust me, if anything goes wrong, that's my fault, not yours. I'm good at teaching normally. I don't, what? It's an open source, you know, the internet. Use it. I'm not perfect because nobody is. It's impossible. Everybody in this room might have different learning style. Different instructors have different teaching styles. Sometimes those styles don't match. It happens. In that case, the university gives you an opportunity to do what? What do you think? Withdraw the course, of course. That's like a divorce, you know. Well, you're not losing anything, just getting your life back. I have emailed you the syllabus, and I hope most of you have read it. If not, you should do it as soon as possible. That's one of your first homework assignments. It gives you general information about the course, about the expectations, what to expect. This is the list of the most important components of this course: lectures, laboratory, exercises, discussions, homework assignments, of course, exams. And naturally, the grade is based on the same components. This is just a copy from the syllabus. And as I like to say, lectures, labs, discussions, homework, they give you like a free money. All you have to do is just do. Be here, do homework, come to labs, discussions. So I assume that some of you already have started answering the pre-survey. And there's a question, what's your most important goal for this course? From my past, I would expect for many of you the highest grade possible, which is the perfect goal. That's exactly why we're here. I want to help you to get that grade. And whether we like it or not, it's based on a certain scale. This is a standard PY 105 course, like other courses. They all have very similar workload. They all have similar grade distribution, grading scales, assignments. Everything is similar, just this is in the spring, which might make it easier or harder. I don't know, it depends. Some people might be susceptible to pollen. I don't know. But only exams, technically, do not depend entirely on your own work. It also is related to some psychological features. Some people have exam anxiety. In that case, well, you should tell me, and I might arrange your smaller room or something else. You know, it's possible. So you should know what's best for you, and tell me. And if it's possible, I'll try to help. Any questions so far? Gentlemen at the back? Okay. This is very important. Things happen, I know. God forbid, car got broken or something else. The best case scenario is not missing any exams. You don't have to do all the labs. The syllabus allows you to skip 2 labs out of 10. I wouldn't recommend doing that. They all related to other topics, you know. Discussions, also. Lectures. The syllabus tells you you can miss 15% of the total amount of the lectures. Again, it shouldn't be like, oh, I'm too lazy today. No. It's something really serious might have happened, and that makes you not to be here. Of course, I don't know the actual reason. If you send me an email and tell me I have a toothache, I trust you on that. But just try to not abuse that ability, right? But with exams, it's much more difficult, because if someone, by any reason, can't take an exam on a due day, I cannot give that person the same exam a day before or a day after, due to obvious reasons. And writing a brand new exam just for 1 or 2 persons, that doesn't seem fair relative to me. It happens sometimes, but I really would ask you trying to stick to the schedule, okay? And frankly speaking, the university also gives you an opportunity to kind of make it up. They just call it, how do they call it? Incomplete. So you kind of make it up later. This is one of the examples of the grading from the past. Very common, very similar to all other gradings. I am not hiding, the procedure. So, in fact, I think it's the best to know beforehand what might have happened. So this is a standard scale for all PY 105, 106 classes. But if you see, the actual scale provided here is slightly different, slightly. What does it mean? Well, maybe up to a half of a point one way or another. There is a reason for that. And very simple. The boundary, like here, for example, between an A and an A minus, the boundary should be large enough. This number, that number, tells you the difference between two consecutive grades. So those are actual students hidden behind those numbers. You see, a very small number, very small number. So these grades are very close, which means they're susceptible to fluctuations. Like, well, first of all, every calculation has an error. And even if you use a calculator, if you run Excel spreadsheet, every calculation has an error. That's a fluctuation. Another possible fluctuation is attendance. I'm taking the attendance using two sources: your clickers and the actual attendance sheet, which I send around and collect back in 50 minutes. So you should, no, this is two-sided, so it should be alphabetically. Just check the name. So for the boundary, for the grade to be fair, the difference between two different letter grades should be relatively stable. That's why I'm looking for a number like that. So this grade minus this gives this, and I draw the boundary. The best strategy, of course, is just not losing any points. If you want a highest grade, just not lose any points. Do the homework, labs, discussions, come to lectures, and, well, calm down before the exam, get a nap, get rested. Read something about test-taking strategies. There are very efficient test-taking strategies. It's a test. You have 2 hours. You have to live through 2 hours. And what should you expect from the exams? Well, I promise you no surprises, which means the exam problems will be similar to something you've seen already before the exam. These are the natural sources: homework, lectures, labs, and discussions. So, from my past experience, everybody who put enough effort in homework, lectures, discussion, and labs gets a good grade. Homework is already open for you, so you can start doing it now. Of course, if you look through the homework, you see many, many problems you can't solve yet. Well, that's on purpose. You can see the homework problems from now to the exam day. So if you want to go ahead of the material and try it out, go ahead. But mostly I do it so you could plan ahead your work. So this is how many problems over 5 weeks have to be solved, and well, now we're here, so let's do this. Now we're starting this material, let's do that, and ahead and ahead and ahead. Trust me, if you try to wait until the last 2 days, and if you try to solve all the homework problems in one sitting, that's impossible. You will lose some points. That's just physically impossible. Some problems are very easy and fast. 2 minutes done. But some might require 15, 20 minutes of work. And it depends. It's impossible to predict how much time one person would spend on each problem. So it's, again, depends on many other circumstances. Discussions. So today is Wednesday. First discussion starts tomorrow, then Friday. Labs start next week. Okay, I guess I've calculated. So 15% means 6 lectures. Assuming no snow days are coming. All homework assignments will be delivered via Webassign. You need to have the access. You don't have to pay it yet. The Webassign gives you some, well, now it's only one, I think, week left. But you can try it for free. And again, you can decide stay or not stay here. And for each part of each problem of each homework, you have 6 trials. If it's not the case, you should tell me. Sometimes, well, of course, I recycle some of the problems. I don't write them from scratch. 90%, maybe even more, taken from the textbook, which is, you know, online for free, or you can buy it if you want to. So this is an example of actually not really wise use of your trials. The Webassign accepts your answer as correct if your answer is within 5 or 6% margin from the correct answer. So if you see something like this, and if the answer number 3 didn't work, the answer number 4 or 5 just couldn't work, because these 2 answers are too close to each other. So if this answer was, well, that's the correct answer, I don't know, this is the answer number 3. If this answer number 3 was far more than 5% from the correct answer, the second answer is so close that can't be right. So again, it's nothing like related to physics per se, right? But it helps you to rise the probability of not losing any points on your homework. Okay, that's it. Questions? Well, this has never happened, but I'm still waiting. I truly believe it is possible. Basically, the previous experience and an effort, 2 major components which bring you to the final grade. The difference in the experience does matter. You know, for example, compare 2 students. One might have been taking advanced placed physics a year ago, another who've never been taking physics and been taking math like 5 years ago. Who's going to be easier and who's going to be harder to get the same level of understanding? Clear, but it doesn't mean that if you haven't been taking physics or math, you're doomed. No. It only means you may need an extra help. That's why office hours, use your office hours, send me emails, talk to your teaching fellows. Currently, we have set up office hours. I will post it on Blackboard. Office hours. So today is Wednesday. So unfortunately, you've missed office hours from 12 to 2. But you still have a chance to go to office hours from 3 to 5 today. And There are office hours tomorrow and on Friday, so use them. Also, I always set up the access to, how do you call it, piazza.com. Some people like it, some not. You don't have to do it. But it's an online collaboration tool, so why not? It's free. Be active means if you have a question, you should ask it. You should send an email. You should come to office hours. Be organized means plan ahead. Again, do not wait until the last minute. That's it. Among these 4 components, the first one is the most important, not the second one. People mistakenly think, oh, mathematics. No. Mathematics for this course is very simple. And even if you haven't been using it for quite a time, it's still really quickly to regain. It's a simple algebra, quadratic equation, linear equation. You should take the math self-test. I will post the solutions later, but even now, if you take it, you spend like 30, 40 minutes on that, and that gives you the feeling what you may review from math. That's it. If you do something and you feel confident, fine. If there's a question you're not sure, maybe it's something to review. How can you review? Well, you can read the book, you can Google it, you can come to office hour and ask a question about this particular mathematical issue. Or if you're doing a lab or discussion, you can call your TF and ask that question to TF or learning assistant. Imagination is very important because we study phenomena. And not every time, actually very little time, we can see an actual phenomenon, like an experiment. In most situations, we have to imagine what is happening. We have to close our eyes and see how things move in space, you know. And using that picture in our mind, we have to start writing some equations, solving those equations. So until we see something clear, we actually can't start using math. And one of my goals is to demonstrate on simple examples how this problem-solving strategy works. We're going to be solving problems here, and I hope that's going to be clear. So clickers, they look like that. You also can use any other device, but it has to be registered. And so let's see where we're at. Now, again, I will be using the personal response system in every lecture. So you don't have to wait until I start asking questions. As soon as you enter this room and settle down, you can prepare a calculator, a clicker, maybe a ruler, or at least straight edge. Now this, let me check. They all might be slightly different, but my system's supposed to be, oops. That might, I didn't want to do that yet. I wanted to check the channel. So I have to go to the settings. 21, oh, okay. Just in case, let's. Now, and I also connected to the cloud. So if anybody using the responseware, this is the number, the session ID you should use, 707-334. 707-334. Every time it's going to be a different number. So, but for today, this is this one. Okay? Now let's follow this procedure one more time. So we should press CH, 2, 1, CH. Mine's green, which means it's ready. Okay, now please tell me your answer one way or another. If I wait long enough, according to the roster, I should have like 100-ish responses. Okay. If you do not have a clicker yet and you don't use the response where, please raise your hand. Okay, so I can stop collecting. Thank you. You should get something. Okay, either a physical thing, or you can download the app, or you can install it on your laptop. You know. Every year when I teach, I try something new. So this is the first time I'm using the responseware. Before that, I've been using physical clickers only. So this is an experiment for me too. Also, I've rewritten many lab manuals and discussions, so we'll see how it goes. This is also interesting. I don't really know how to explain this, but 10% of the students didn't add 0 and 1 correctly, or they just didn't care what button to press. One way or another, that's probably not the best attitude. I'm not going to look inside and see, this is just a test of the technical capability of the system. It works, but strictly speaking, I could look inside and find out who did what. But I'm not gonna. All right, 62. Ready, that's good enough for a first lecture. It's actually a good percentage. I've had less in the past. So let's use it one more time. You should check your access to Webassign and Blackboard. Every day after the lecture, I will be adding the links to the video. So if you want to refresh some part of the lecture, you can do that. If you've missed a lecture, you can see it later. Also, I will be adding the slides every time. It's not going to happen 5 minutes after the lecture, but maybe 2-3 hours later, my notes, my slides will be available for you as well. Okay, so. And I think I haven't mentioned that part which on a Webassign called pre-survey, self-test. Those assignments also give you points. So use it. Free money. Doesn't take much time to actually do it, and it helps me. If you read the instructions, it helps me to gauge the audience and to make adjustments one way or another. This course, again, is a standard course. My aim is always on the average student. I don't know who is the average student here, but an average in a good sense. An average from the point of view of background, knows something from math, remember maybe something about the world, has experience of learning and stuff. So for some of you, this course might be very easy. If that's you, prepare to be bored. But for some of you, this course, lectures in particular, especially because of pronunciation and grammar, whatever, might seem like a slightly too difficult. I don't know. So your feedback helps me to find that level, the average level. So less students would be bored and less students would feel, well, some kind of a heaviness. Okay? Let's see. Oops, where is it? Actually, what I want to do, I want to save this. So, 169. 169. 1 hard, 6 hard and fun. You shouldn't flatter. And 9, all of the above. I don't like 9. It's kind of like answering the question about 0 plus 1 is not 1, you know. Actually, there is some logic here. If you read, there are natural choices which people have been given for every time when I ask this question. But all of the above, none of the above could work. You may have something in mind, but all of the above couldn't. Why? What do you think? Yeah. Exactly. There is a contradiction. So if you choose all of the above, you miss that contradiction. And who knows, maybe there is a question on the exam similar to this. So on the exam, if you, again, and some questions might be multiple choice questions. But still, it doesn't mean you just randomly choose the answer. You should give some thoughts first, right? But I'm not saying it's wrong. I just disagree. It's not hard. That's a myth. There is a reason for that myth be existed, but it's not. So, for example, to keep it in perspective, it's much harder to learn how to walk a rope than to solve a problem about how to walk a rope. And to solve this problem, there is a very simple, short, actually clear strategy. To solve any problem in physics, there is a clear strategy. And as long as we get a better understanding of that strategy, it's not hard anymore. All right. What do we do? Exactly. It says, do not read this slide. So don't read it. This is just a copy of some material from the last pages of the syllabus. The syllabus gives you 3 pages of all topics we'll be covering, all of them. And this is what we're going to talk about today, tomorrow, next week. So what you should feel is the amount. It's a lot. It seems like a lot. And of course, having just 50 minutes, not even 60, 50 minutes a lecture 3 times a week, it's impossible to cover all these quantities, categories, definitions equally. So I have to talk about some things more, and I have to talk about some things less. And to compensate that lessness, you should read textbook. Which textbook? Doesn't matter. Physics hasn't changed much. As I said, homework problems have been taken. Majority of homework problems have been taken from that particular textbook. But the theory is the same no matter which physics book you want to use. Okay? Today we start from this motion. Anybody want to sign in? Raise your hand. Okay, could you please pass over there? So this is a copy of my slide. This is what I want to do. See? Taking this page and move it, pull it. So now I want to ask a question about this yellow puck. Did it move? Did it move? Yeah, the yellow, well, it's a nut, it's a puck, wherever, you know, the yellow thingy. Did it move? What do you think?
Yeah.
What do you think? What do you think? Anybody thinks no? Please, why? Well, please stop. You're absolutely right. You're all absolutely right. You're all absolutely wrong. Because this question is just wrong question. Because if you look at this pair of objects, yeah, no matter what I'm doing, the distance between these two objects stays the same. But if you look at this and this, for example, it changes. So what does it tell us? The motion is relative. That's it. So if you have a question, did it move? You should ask relative to what? And only then you can answer. But of course, in 90, I would say 5% of the problems we have to solve, of the situations we have to discuss, it doesn't tell you relative to what. It just tells you a driver rides a car, blah, blah, blah. And you read and you read and you read, it doesn't tell you relative to, what does it mean? What do you think? The car, yeah, you read the problem, car is traveling from city A to city B, but it doesn't tell you relative to, you can't read this, you don't see that sentence. What does it mean? Anyone? Take a guess. Of course, that's always an assumption. There is a natural assumption. There is a natural assumption for everybody, for every problem, for every situation. If it doesn't tell you specifically relative to what, it means relative to the ground, relative to the earth, you know. And 99, 6, 7, I don't know, problems out of 100 mean not telling, but mean relative to the ground. But sometimes it tells you relative to a cloud, relative to a person standing on a raft or wherever. In that case, of course, you should consider motion relative to that object. That system of objects which we use to describe motion has a name. We call it reference frame or frame of reference. And that single point relative to which we analyze the motion, we call the origin. That's it. So basically, you should ask, what's the origin? Where is the origin? And relative to this particular origin, every object has a particular position, and if position changes, the object is moving. If it doesn't change, the object is not moving. Simple, right? So, let's say you need to, you want to, well, if it's you, get to this treasure chest. You have possible ways to get to this. So, for example, like this. For 2 blocks down, 1, 2, 3, 4, 5, 6 blocks to the right, 1, 2, 3, 4 blocks up, 1 block to the left. This line has a name. In everyday language, we call it a path. In physics, we call it a trajectory. And we can measure the length of this line, the length of the trajectory. That's what we call the distance. The distance traveled by an object is a length of the trajectory. Can distance be negative? No, never. If we measure distance, it's either 0 if nothing has been moved, or we increasing number 1, 2, 3, etc., etc. Now, the displacement, this a loaded word. It has several different meanings. For example, an action. We are displacing something from one place into another. The result of that action, the object has been displaced from one place to another. And finally, in physics, there's another meaning for this particular word, a straight arrow which connects the initial position of an object and the final. There is always an initial position, and there is always a final. Sometimes they might coincide, but still. That's what we call initial, the start. That's what we call final, finish. And we always can take a ruler, draw a straight line, and add, well, a pointer, a direction. This arrow has a name, also a displacement. So, it's very important to remember the exact definition of each physical quantity, of each physical variable. So if your teaching fellow asks you, what is the definition of distance? Or define the distance. You should say, what should you say? That's it, the length of the trajectory. If what is the definition of displacement? Well, you should say that's a straight arrow. This arrow also has a mathematical name. How do we call it? Vector, yeah. Oops. Okay. I'm going to skip this question. I'll start from tomorrow, from this question on Friday. So first, I want to point at this picture, right-hand triangle. If you remember, my displacement was a straight line, but also I could have moved like this, right up. And we can see that very often we have to deal with the figure of this particular shape. We know the name from geometry. We call it a right-angle triangle. And what do we know about right-angle triangles? Please, someone tell me something we know about right-angle triangles. Perfectly right. That's actually a definition, and it's always advisable to start from a definition. A right angle triangle is a triangle which has a right angle. And right angle is the angle which is equal to 90 degrees. What else do we know about right triangles? Yes? That's correct. And that actually, that relationship also has a name. Pythagorean theorem. What else do we know? Yes? Absolutely. And everything you just said, you will be using in the future at one point or another. But in one word, this is what we know about right triangles. So you should refresh if you still need it for the future, because we're going to use it. Now, as we said, an arrow has a mathematical name. We call it a vector. For example, here, how many vectors do you see? Please press the button. If you see only one vector, press 1. If you see 2 vectors, press 2. If you see 3 vectors, press 3. If you see 4 vectors, what should you press? 4. And what did you just do? No. While answering to my question, what did you do? You know, and you know, everybody knows, you recognized the pattern. This is a simple pattern, but you recognized and you used it. And the pattern recognition skill is the most fundamental scientific skill. So from my personal point of view, physics is the best tool, the best instrument to kind of advance that pattern recognition ability. So everybody who's taking this course in 14 weeks or so will become a perfect pattern recognition, I'll say, person. I wouldn't say device, yeah, person. All right, it's been 62. I'm not going to wait for the last one. The gentleman in the back, please tell me, what's wrong with this one? And why is it wrong? Why? 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 Anyone? Not very clear. Because what?
It's always the shortest distance between points.
There's a shorter answer, yes. There is a shorter, yes. All right, I almost have no time left, so I'm going to give you away the answer, because that's a definition. That's what we're doing. There's a definition, well, in that situation, a definition of a vector, and there's another object, and you try to match. If they match, that's a vector. If they don't match, that's not a vector. That's it, very simple. And in physics, there are many definitions. And this is one of the kind of a reasoning we have to do every time. So this doesn't match because it's curved. By definition, a vector cannot be curved. What's wrong with this? What's a contradiction? Two pointers, two directions. A vector must have only one. So this doesn't have any. So 1, 2. Now, the motion, yeah, if you remember a picture, might be composed of several individual smaller motions. Yeah. For each individual motion, there's its own displacement. So if you've moved from here to here, that's a displacement. From here to here, another. That's going to be your total or final, or we say net displacement. And this particular I'm done. I'm sorry. I'll start from this on Friday. It's going to be next class and we have to leave, so that's why I can't spend any extra time. So that's why I always start and I always finish on time.
Did I use this to answer the question? How can I know my email? I have registered the account on the...
So, to use the phone, you needed to purchase a license. Did you? License. Maybe that's the reason. My suggestion, please read the part related to this and send me an email. And I'll try to clarify instructions and send it to the whole class. Maybe you're not alone who has a similar situation, okay? Yes. For the clicker, you don't need the code, but you need the channel. That's 21. Yes. It's supposed to be, yeah. This, don't worry about this. It's going to take a while before everybody gets,
Hi, Professor. I
yes.
asked you about a discussion section to switch into.
Yeah, we can definitely. We can definitely do that. Just, do you have a class right now?
No, I don't.
Okay, so can you just maybe wait like 5 more minutes?
Professor?
Yes. You can keep on this page and bring it me tomorrow, or I mean next time.
And I also want to ask you because this assignment it's kind of hard for me to concentrate and I switch into
Yes, but again, you need the drop form, so I will sign it for you. Just give me a second. You can wait, and you can give me later. Just this. You can hold on it until you have all you need, and give it to me later.
Okay, thank you.
All right. Is it off? Please unplug everything.
Oh, yeah. I see this was into the discussion section. So.
Yes. Yes.
Is this one recorded?
Yes.
All right, thank you. Sorry? Yeah, I kind of got baby face. Yeah, I took it okay, perfect. Yeah. Do you have a question? No.
doing science. Yeah, I like it. It's amazing. Yeah. Yeah, human phys is kind of ridiculous. This is that word. Yeah.
Oh, I actually saw the first
With Buston? Pete Buston? Yeah, marine biology 260. Yeah, he's cool. It's a good class. So, yeah. You just learn about all kinds of different levels.
We can do it here. You do have the form to sign?
Oh, I don't have a form. Yeah.
You need the form.
Oh, okay.
I don't have it. You should find it as probably if you can find it at the department office or.
Oh, okay. All right.
Fill it out. I just sign it, and you should bring it back.
Any problems with the room?
No, everything's perfect.
Nobody was confused. I saw the signs.
Well, a couple of students
Went to the room.
left from, yeah.
Okay. I just talked to Grace. She was happy with what.
Yeah, I think good.
All right. Thanks.